Alright, so we're going to go over Lewis structures today. For the most part, it will be a review from what we learned last year, with a little bit more thrown in. But with Lewis structures, we're just drawing down the atom and their valence electrons. So I'm going to go through the first 10 really quick to kind of remind you of this, and then we'll move on to actually building molecules. But if I have hydrogen, that's going to have one valence electron. And valence electrons, remember, are the electrons in the outermost shell. So for hydrogen, this is in that shell, that's the outermost, so it's got that one valence electron. So I would write hydrogen and one dot. Okay, the dot is going to represent my electron in this. Helium is two valence electrons, and so we would go helium. This is the only shell where two electrons is enough. Okay, because this is the only shell that does not have the p orbital. Right, there is no one p orbital, so we can only have two electrons here. We'll move on then, and we get to lithium, which has three electrons, but only one of those is a valence electron. So it is going to look like hydrogen. Then we have beryllium, which has four, which is two valence. And so we go Be. And now we're going to separate those electrons, because this one wants to fill all the way up and not to 8 electrons, not just to 2. So we're going to separate those 2 electrons. We're going to have one on the side and one on the bottom down there. Boron has 5 electrons. 3 of them are valence, so we're going to have boron 1, 2, 3, and there is nothing up here in this top box. Carbon has 6 valence electrons, or 6 electrons, 4 valence, so we'll go 1, 2, 3, 4. Remember, don't sit on each other's laps until you absolutely have to. Nitrogen, 7 electrons. 5 of them are valence. So now we get to where we have to sit on each other's laps. So we'll put them like this. This, when I have a pair of electrons already, is called a lone pair. Oxygen has 8 electrons. 6 of them are valence electrons. 1, 2, 3, 4, 5, 6. So he has 2 lone pairs. Fluorine. And again, we are worried for Lewis structures about the valence electrons. We're not worried about all the electrons it has, because only the valence electrons interact. So he's got 7, which means that 3 of his are lone pairs. 3 pair of his electrons are lone pairs. And last we have neon, and neon is a noble gas, and what a noble gas basically means is that it has a full octet, so it is not going to bond with anyone. Okay, so then if we go with this and we're going to draw molecules, let's start with something really simple. I have H2. Well, I count up the number of valence electrons that each of the atoms have. Now, it doesn't mean that those electrons have to go with that atom, but we have to stay with that number. So here I have hydrogen. I have 2 hydrogens. Each hydrogen is going to have 1 electron. So altogether, I will have 2 electrons that I can have total in this molecule. So I'll draw hydrogen, and he's going to have 1. And then I'm going to draw my other hydrogen, and he's going to have 1. If I put 2 between 2 atoms, that is called a bonding pair of electrons. And I can rewrite that as a dash, not a dash line, just a line, as a bond. Okay, so this would be a hydrogen molecule, H2. That's how we would represent it. A little bit more complicated if I say I have H2O. Well, I have a hydrogen with 1, a second hydrogen, second hydrogen with 1, and an oxygen with 6. Okay, so I'm going to start drawing this. I'll draw my oxygen. 1, 2, 3, 4, 5, 6. These are going to be lone pairs. I cannot forget to draw those in. My hydrogen can go here to fill in this box, and my other hydrogen can go here to fill in this box. So when I draw this out, I would have my oxygen with a bond here and a bond here to one of the hydrogens and to the other hydrogen. Okay, that would be my Lewis dot structure for water. Let's look at something a bit more complicated, carbon monoxide. Okay, so CO. Well, carbon is going to have 4 valence electrons. Oxygen is going to have 6 valence electrons. You can start with either one of these because there's only 2 of them. Usually you would start with carbon because it wants the most bonds, but when you only have 2, that's, it doesn't matter really which one you start with. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to take my carbon now, put it here so that I can bond it. 1, 2, 3, 4. We got to think about double. So this is going to be a single bond here where I've got these 2. We can double and we can triple bond things. Well, here's going to be my double bond. Okay. And now I'm stuck because my carbon still needs 2 more electrons. My oxygen is done, but my carbon is not. So what is going to happen, one way to look at this is that this electron here is going to move down and take this spot and fill that in, which is going to give me this molecule. And now I'm going to share those between it so that these 2 electrons up here are now being shared with my oxygen and my carbon. Okay, which we can do because that satisfies the octet rule. So when I redraw this, I would say that I have carbon with a lone pair here, and it's going to have a negative charge because it's going to be taking this extra electron from oxygen. It is triple bonded to oxygen, which is going to have a positive charge on it. Alright, so that is Lewis structures.